Hello, good afternoon, guys. Welcome to Origin's computer classes again. In my earlier video, I have discussed about what the concept of functions in C, right? So where I have actually discussed what was the basic fund of function. It actually takes some values, some parameters, performs some operations on it, and then returns a specific result, right? So in here, like we actually performed some function. Okay, we added two values, but uh, today what we'll be discussing is an advanced concept of functions, that is recursion in C. Okay, and then after this video, we will be in the upcoming video we will be discussing some questions based on functions in C, that will be including the recursion. Recursion is also a kind of function. Now, what kind of function is it is? Actually, recursion is a repetitive function. When we want to perform some repetitive actions, like say calculating the factorial of a number, right? Calculating the factorial of a number, where we actually, you can look at it as an iterative approach as also, where we'll run a loop up to that number, and then we consequently continuously multiply from 1 to all the numbers up to that number, and then we get our result, right? But in recursive functions are such functions which performs tasks, okay, repeatedly, the same tasks that you give repeatedly, and then returns some result after performing some operations, okay, repeatedly, then we get the value. Okay, let us take some examples, right? Like here, let me write it from the beginning. Okay, let me do this task. Say, if I ask you to write a program to find out the factorial of x, say x is a number called 5. What will you do? You will be taking a variable, say int f is equal to 1, right? And then say for int I is equal to 1, I less than x, I plus plus, okay, opening brace, f is equal to f into I, and this writing this will do all your tasks. Okay, so how will it be calculating? Say I am taking, say I is equal to 1, then f is equal to 1 into 1, that is your 1. Okay, I is equal to 2, then f is equal to 1 into 2, that is your 2. Okay, I is equal to 3, f is equal to 2 into 3, that is 6. And similarly, I is equal to 4 is means f is equal to 6 into 4, that is 24. And when I is equal to 5, f is equal to 24 into 5, that is your 120. So we have actually approached till the factorial of the number in this way. Here if you see, we have used actually two extra variables, this f, right? Actually this f will be used actually because we need to store this final value somewhere. Okay, but this loop variable, this I, is unnecessary. Okay, we can also calculate this without a need for without the support of this I variable. Here where the concept of recursion comes. We will be actually the first and foremost advantage of using a recursive function is that we actually reduce the use of variables, because variable actually means taking extra memory space, right? That is what it is. When, because we need to store some value, and storing a value means it needs some space in the memory of the computer. Okay, so this IO is also occupying some extra unnecessary space. Okay, now how we can consider, we can consider a function. Say I am defining a function, say f of x is equal to, see, factorial of 0 is 1. It is a predetermined fact. Okay, so when x will be 0, we can write, when x is equal to 0, the value of fx will be 1. Fine, no problem. But otherwise, if x, the value of x is greater than 0, then it is x into, we can say, see, if I consider 5 factorial, it can be written as 5 into 4 factorial. So actually, what we will be doing, as this function is calculating the factorial, we can say 5 factorial means 5 into f of x minus 1, because f of x is calculating the factorial. So f of x minus 1 will be calculating the factorial of f x minus 1, right? So 5 factorial means actually 5 into 4 factorial. Okay, so let us see how will it work actually. See, say x equal to 5. So f of 5, f of 5 means 5 is greater, 5 is greater than 0, right? So 5 into f of 5 minus 1, that is 4. Fine. Then 5 into f of the f of 4. What will f of 4 say? F of 4 means 4 into factorial of 3, right? So 4 into, this will call, see, as per this definition, the f of 4 means 4 into f of 4 minus 1, that is f of 3. Fine, very good. Now 5 into 4 into, now f of 3 again means, see, a 3 greater than 0, right? 3 is greater than 0. So 3 into f of 2. So 3 into f of 2. Okay, again 5 into 4 into 3 into f of 2 means what? 2 is greater than 0, right? So this definition, 2 into f of 1. Again 5 into 4 into 3 into 2 into f of 1 means 1 into f of 0. Fine, 1 into f of 0. Okay, fine. So now f of 0, we have already defined that when f of 0 means x equal to 0. So when x equal to 0, so f of 0 will actually mean that the value of f of 0 is 1. Okay, so that is it. 5 into 4, 3 into 2 into 1 into 1. So this is your 120. Okay, so here you can see that we are not requiring any extra variable. We are doing everything with this variable x only. Yeah, we will be requiring an extra variable for just storing this value 120, because this is an integer value, right? That is actually a normal concept of function. So for this function will be returning the value 120, right? And that 120 will be in the main method, it will be stored in some variable. Okay, so that is a concept of function only, simple function. But the for doing this entire process, we didn't require any extra variable actually. Okay, so what we can do is, see, first let us define the factorial function. Say how to implement it in the code. In the code, we can give the function name as fact, say, and taking an argument x. Okay, as we are declaring this variable, the data type of x is integer. Now, first, let us determine our base condition. Okay, so the concept of recursion, you can say, is like a staircase. So when we are putting our first step into the first step of the staircase, okay, then we actually first look for the next upcoming steps, and we first see the where we are going to stop. We will be stopping whenever the next floor comes, right? Here also same, so that is the base. Okay, every floor, we, in every floor that we stand, that can be considered as a base. Above the base we stand. So here also, wherever we are stopping, that can be considered as the base case. Okay, so that is it. So recursion is can be considered as a repetition of function call. It is like a number of steps in a staircase, it can be considered. Okay, so here, first see, first we will be defining our base case, because when we actually see a huge number of steps in a staircases, say you are going to such places where the number of steps in the staircase are 200, 300. So you first see where the steps are going to end, right? Because the a huge number of steps can mean like, so that's a fear, because some aged people, it becomes difficult for some people to go through such long number of steps. So we actually first see where we are going to stop. Okay, so you can consider that. That is why we actually write the base case first. Practically there are some other reasons, because actually after the function call, if we write the base case, because recursion means we will be calling the functions repetitively. So after the function call, if we write the base case, then that will be treated as some other stack variable, some, like, it will be stored differently in a stack memory. Okay, so the concept of stack memory we will be discussing in our upcoming videos. For now, just uh, take the examples, just keep in your mind the example of staircases. That is why we write the base case first. Okay, so for x equal to 0, what we are returning? We are returning simply 1. Fine. We are returning 1. So return 1. And after returning, it will be stopping definitely. Otherwise, what will it be doing? Actually, we will be returning the other condition, because otherwise, if x not equal to 0, see, you might say that it can be less than 0 also, but we are not considering, we are considering that user is giving a positive value only. Okay, or say you can give here a condition, if, because the factorial of numbers can be calculated only for positive integers, right? it is not preferred to calculate factorial for negative integers. So if x less than 0, then we will be simply returning -1. Okay, so this -1 would mean that it is an invalid value. Fine. Otherwise, if x equal to 0, we will be simply terminating this condition. And otherwise, if in case of positive other values, then so x into fact this same function of x minus 1. As simple as that, this same representation, nothing to worry, but just this integer, because we are writing a program, we need to mention the data type of the variable. Nothing more than that. Okay, so that's all about our fact function. Now let us define the main function. So int, say we are giving x equal to 5, and we are passing the same value to the fact function. Okay, and as it is returning some integer value, right? So we should store this in some integer variable. This is a simple concept of function. So that 120 for 5 will be stored in capital F. Okay, that's all. So let us check if it is giving the right output or not. So okay, so let us check a prerequisite first. So if the value of x is negative, if the value of x is, I mean, if the value of f is -1, if f equal to -1, then simply print printf printf invalid invalid value. Okay, otherwise we can calculate the, I mean, we can print the value in f after performing the operation. Right, calculation is being done by this fact function only. So whatever be the value of f, that will be printing. So for x equal to 5, we should be getting 120. So let us check. Yeah, 120. So let us change the value for say 7. What is 7 factorial? 5040. We should get 5040, right? Let us delete this value and wait just a second. There may be, oh, I've changed the value and I have not saved it. Yeah, so I need to save, and yeah, saved it. Then it should give, yeah, 5040. So this is the value. Okay, right. So this was the concept of recursion, where we can actually implement the same process by using very less number of variables. So we have actually reduced, not to say two, we have actually reduced one variable, the loop variable, in this simple example. Now see, in higher examples where we will be writing the complex programs, we will be actually reducing quite a large number of variables, right? Now, where we actually use recursion, basically, see, both iteration and recursion has their own advantages. It is not that we will never be using iteration for its disadvantage that uses large number of variables or like something like that. In some cases, like say for printing the sum of series, for printing pattern, it becomes very difficult with recursion. It becomes easy with iteration, right? Can be done in both the ways. Everything can be done in both the ways. You're getting my point? But part, some programs are easy with recursion and difficult with iteration, and some are easy with iteration and some are difficult with recursion. So we need to understand in what kind of program we need to use recursion actually. So it is mainly used in, so uses of recursion. Okay, uses of recursion. See, so our first and foremost use is in non-linear data structures. In non-linear data structures, right? Non-linear data structures. So now what are non-linear data structures? Trees, then graphs, then trie, all these comes under non-linear data structures, right? So those we will be discussing in our upcoming videos, right? So all those non-linear data structures, those becomes very difficult with recursion. Okay, so example is trees, okay, then graphs, then trie, etc. Fine. Next. Yeah. So it can be used in non-linear data structures, some linear data structures also, like you can say stack. Stack can be implemented using recursion, can be implemented using loops also. Okay, but using recursion, it becomes easy. Then also you can say queue is another data structure. So these are some uses. Okay, these are some uses. Stack actually we have already seen when during our Python videos, the execution of how the execution of program occurs, right? The C program also executes in the same way actually. Actually, any programming language, that the first statement comes first, then the second statement, then it actually, say if I talk about stack, I am just giving a brief idea. Say this is a stack, okay? So you can consider it like a shelf of books are kept here, okay? Uh, a number of books are kept here in a shelf, okay? So say this is book 1, book 2, book 3, book 5. So when you will be picking up the book, you will be picking up the topmost book first, right? And then the second book. So here we actually have a variable called top. This top will be decreasing when we will be picking up the last data. So here actually data can be processed in one direction only, in the LIFO order. LIFO means last in, first out. So actually we'll be picking up this book first, then the second book, then the third. Okay. So from last to first. So that is what stack data structure is. And queue is nothing actually. This we are picking this up from the front side, and we will be actually removing. So like we will be, what to say, here we actually keep the books insertion, like we when you keep the books, you keep it from the same side, right? You will be say inserting the book 1 first, then book 2 first, then book 2, book 3, then book 4, in this way from the same direction. And then when we will be picking up, we will be picking up from the same direction itself, in this direction only, right? In this direction only. this is the direction of your picking up, right? So this is what it is. Here from this side you will be picking up. But in case of Q, you actually keep the books. Say this is a horizontal shelf you are having in a library. Fine. So you will be, say, inserting the books from this side. Okay. Inserting the books from this side. From this side, you are doing your insertion. Insertion. And from the other side, you will be collecting. I mean, or collecting, or what to say, because picking doesn't go right here because this is a horizontal shelf. So you'll be collecting the books from this side, or better to say, you will be removing from the shelf. So removing from the other side, right? So in stack, insertion and collection, insertion and deletion from the same side, insertion and deletion of the data. But Q, the deletion is from one side and the insertion is from other half, right? So that was the, so these two data structures can be implemented using recursion. Okay. And now we can consider some advantages of recursion, like it makes the code simple and complex, the complex code simple, right? Because of course we are reducing the number of variables. Okay. We can say it it s- makes the code, advantages of recursion, advantages, say it makes the code simple, makes the code simple. Okay. Second, increases code readability. Reading the code becomes simple. See, with loops, you are using, you in some cases you may need to use too many nested loops and too many loops to perform the same operation. You are using a lot many number of variables. So which variable is performing which task, it becomes difficult to understand. But recursion, as it is reducing the number of variables, so actually readability becomes better for other debuggers. Okay. um, Facilitates problem solving, better to say. Of course long problems can be solved easily, you as you have seen. Facilitates problem solving. And last, you can say it actually saves time. Saves time and space. Okay. Now, so these advantages are, uh, actually recursion itself uses a stack data structure for its implementation, right? Say, as I have told you, every part of the program is stored in a stack, right? Similarly, eh, similarly, the parts of this recursive program also are stored in a stack only. So what will it be doing? Actually, this function, when this function will be called, so for the fact of 4, say when I am calling fact of 5, fact of 5 will be calling fact of 4. For fact of 4, it will be calling a separate phase stack. Okay. And again, so fact of 4 will be calling a separate stack with fact of 3 and with the tasks of fact of 3. Okay. So in this way, say by chance if you miss the base condition, then it will give a stack overflow. And of course, stack overflow is a very bad thing because it may crash your computer memory. Fine. Second is, it reduces your difficulty in, say, It is very easy to understand. It increases the code readability, but it also becomes very difficult to debug because it calls the function, the function calls itself. Okay, so which call is doing which what task, it becomes very difficult to understand. Fine. And because it becomes very difficult to debug, because see, in case of iteration, you know which the variables can still be understood, which variable is storing what data, but the function calls are very difficult to understand which function call is for what task. Okay, and so there are many other disadvantages, but these are the two most prominent disadvantages of recursion. And also, better to say, it makes the program slower. It makes the program slower. Slow, basically. It's a slow process. Of course, because for a very large number, it the function needs to call again a function that with that also very large number. Okay. And of course, these large data make the program slow. Okay. So that was all about today's lecture. In the upcoming lecture, we will be discussing about we will be first discussing some questions from the function concept of function and this recursive function also, as well as we will be discussing some types of recursion. There are four types of recursion. Whatever we have discussed today was the linear recursion. Okay, there are some other three types. We will be discussing them in detail in the upcoming lecture. Thank you, guys.